Hi students, I am Neeraj sir. Today we will learn a new topic, that is mole concept. This topic is very simple and interesting. So if you go in market and ask a shopkeeper, give me 1 kg of sugar, he will give you. Okay, or if you tell him that give me 10 grams of cardamom and any other thing, so he is able to give you. But if you ask him to give 1 mole of water, or if you ask him to give you 1 mole of sugar, he will get confused, because this mole is not used in day-to-day life. This mole is used in the language of chemistry. So why this mole concept is arrived and why it is used? While doing chemical reactions, various substances or various molecules or atoms react with each other to give some products. So that exact number of molecules reacting should be known and should be calculated easily. So that's why mole concept is introduced. So what is exactly 1 mole? So scientist Avogadro has done pioneering work in this concept, and he has found that 1 mole of every substance has 6.022 into 10 raised to 23 molecules. It may be molecules, ions or particles. So it is same like a dozen. If you consider 1 dozen of apples, it will give 12. In the same way, 1 dozen of banana means 12 banana. 1 dozen of eggs means 12 eggs. In the same way, 1 gross of notebook means what? 144 notebooks. Here, in the same way, 1 mole of water. So 1 mole of water means what? 18 ml of water. So how 18 ml come? It is nothing but the molecular mass of water. So 1 mole of every substance is also corresponding to its atomic or molecular mass. See, 1 mole of any substance contains this much particles. These particles may be atoms, molecules or ions. And in the other words, you can say 1 mole of substance is equal to atomic mass or molecular mass in grams. For example, if you consider H2O. So what is atomic mass of H2O? Here you know 2 into 1 plus 1 into 16 means 18. So 18 gram of water means what? 1 molecule of water. So 18 gram water corresponds to 1 mole of water. So in this way, molecular weight, if expressed in gram, it is 1 mole. So 1 mole of every substance have different value. Now this Avogadro number, this number is known as Avogadro number, and it is denoted by capital N and small a. So here we can calculate different things by using this. So for calculating number of moles, we have a formula. Number of moles, it is denoted by small n, is equal to weight in grams upon molecular mass. So why we are using this formula? We are using this formula because if you consider 100 pens are there, you have to distribute among 10 students. So how will you distribute 100 divided by 10? So you will get answer as 10. In the same way, if you have 100 chocolates and you have to distribute among 20 students, so how much each student will get? So simply 100 divided by 20. So you will get answer as 5. So 5 chocolates to each. In the same way, if you have 36 gram of water, so how much moles are there in 36 gram of water? Simply you have to calculate weight in grams, 36 upon molecular weight of water. One water molecule means what? 18 gram. So 18. So here you will get as 2 moles. So N is equal to 2 moles. In this way you can calculate number of moles if weight in gram is given. So this is the basic concept of this mole concept. I hope you have understood up to this. So students, let us see how to calculate number of moles and how to solve this type of problems. See, you have given how many molecules are there in 66 gram of CO2. So directly you cannot find molecules, there are some steps. So first you have to find number of moles. So number of moles can be calculated by this formula, weight in grams upon molecular weight. So weight in grams is given in question 66 gram. So put the value in the numerator 66. Then molecular weight. Molecular weight of CO2 can be calculated by adding atomic masses of C and this O2. Simply carbon is having 12 atomic mass, oxygen, single oxygen is having 16 atomic mass, but 2 oxygen are there, that's why 32. So C 12 plus 32. So 12 plus 32 is 44. So 44 is the molecular mass of CO2. So this molecular mass, if you do a lot of problems, you will remember most of the molecular mass of like general molecules like CO2, water, etc. So here 44 value should be put in the denominator. Molecular weight is 44. So by dividing 66 divided by 44, you will get answer as 1.5. So this small n is number of mole, and always remember that mole is written as MOL. Abbreviation for mole is MOL. Like kilograms we are writing only kg. We are not writing in full always. In the same way mole, always you are writing in 3 words, that is MOL. So this is the 1.5 mole is the first step. Means you get 1.5 mole is present in 66 gram of CO2. But how many molecules are present in this? So you know that 1 mole of every substance or 1 mole of every compound element or molecule will contain 6.022 into 10 raised to 23 molecules. Now how much molecules will be present in 1.5 moles, because 1.5 mole is the answer. So you have to calculate about this. So 1.5 mole of CO2 will give 1.5 multiplied by this. Okay, simple calculation. 1 mole give this, so this much this. Means 1 pen cost rupees 10, so 2 pen will cost 2 into 10, that is 20. In the same way, 1 mole will cost this, so 1.5 mole will cost 1.5 into 10, this much. Okay. Now after calculation, you don't have to calculate 10 raised to 23, only solve this one, 1.5 into 6.022. So you will get answer as 9.033 into 10 raised to 23 molecules. So in this way you can calculate number of molecules of different compounds. So this is very simple. I hope you have understood. There is one question in your textbook, question number 7. Deduce the number of molecules of the following compounds in the given quantities. So here different molecules are given or compounds are given. So first one is 32 gram of oxygen. So you have to remember this 32. This is weight in grams. And molecular weight of oxygen, you know that. See, oxygen means O2. You know that oxygen is always present in the molecular state, that is O2. So single oxygen atomic mass is 16. So O2 means 2 atoms are there. So 16 plus 16, so 32. So 32 units is the molecular mass of O2 molecule. So what is the formula for number of moles? N is equal to weight in grams upon molecular weight. So here simply weight in grams is given as 32, put the value 32 grams, and molecular weight is 32 units, means it is unified mass. Okay, now 32 divided by 32, simple, 1 mole. So number of moles present in 32 gram of oxygen is 1 mole. Now for finding number of molecules, you have to calculate, you know the formula. 1 mole of any substance is equal to 6.022 into 10 raised to 23 molecules. So here you are also getting the same answer, that is 1 mole here. So that's why no need to calculate something else. This is your answer. 1 mole of oxygen equal to 6.022 into 10 raised to 23 molecules. So this was very simple. So let us see the next example is 90 gram water. So you should know what is molecular weight of water. So you all know that how to calculate molecular weight. So H2O, 2 hydrogen, 1 oxygen. So 2 into 1, because 1 is the atomic mass of hydrogen and oxygen atomic mass is 16. So 16. So 2 plus 16, 18. So 18 is the molecular mass of water. So how to calculate number of moles? Number of moles can be calculated by weight in grams upon molecular weight. Weight in grams is 90 gram, which is given in the question. Okay, so 90 gram in the numerator, and molecular weight is 18. So 18 in the denominator. So simply by dividing you will get an answer as 5. So this is the number of moles as 5. Now next step, number of molecules. So number of molecules, you know that 1 mole of any substance will contain this much of molecules. So therefore 5 mole of any substance, that is in this case water. So 5 moles of water will contain 5 into 6.022 into 10 raised to power 23. So this, after multiplying this 5 into this 6.022, you get answer as 30.11. So 30.11 into 10 raised to 23 molecules. So therefore 90 gram of water will contain 30.11 into 10 raised to 23 molecules. Students, let us see the next example. 8.8 gram of carbon dioxide. So weight in grams is given 8.8. You require molecular weight of CO2. So you know that carbon weight is 12 and oxygen is 16, but 2 oxygens are there, that's why 16 into 2. So 12 plus 32 will give 44. So 44 is the atomic mass of, molecular mass of CO2. Now number of moles, N, can be calculated as weight in grams upon molecular weight. So weight in gram is given, that is 8.8, and molecular weight we have calculated, that is 44. So 8.8 divided by 44. So this calculation you can do, it is very simple. Now 44 you can see here, 44 1, 44 2, but is it point, so you will get 0.2. So number of moles is 0.2. So we got the first step, that is number of moles 0.2. Now number of molecules. Number of molecules can be calculated in simple way. 1 mole of CO2 contains this much molecules. Therefore 0.2 mole of CO2 will contain 0.2 into this much. This is simple unitary method. So after multiplying 0.2 into 6.022, you will get answer as 1.204. This 10 raised to 23 will remain as it is. Simply multiply these two, you will get answer as 1.204 into 10 raised to 23 molecules. So therefore, this is the final answer. Therefore 8.8 gram of carbon dioxide, that is CO2, contains 1.204 into 10 raised to 23 molecules. As simple as that. So I hope now you can solve this type of example. Friends, these 3 are your homework example. First 3 examples I have solved. This next one is given in your textbook, and these 2 I have given extra examples for your practice. So these also you have to solve in the same way which I have taught you. Now first one is 7.1 gram chlorine, second is 36 gram water, last one is 49 gram sulfuric acid. So I hope you will solve this in proper way and you will get the correct answer. If you are having any doubt, you can ask me in WhatsApp or you can call me.